Hi, so welcome to this new video and also welcome to all my new subscribers. Thank you for that. Today I want to show you how I solder these USB sticks with the CH552 chip. I have some bare PCBs here and also the parts that are needed for it. Some switches, the chips itself. And yeah, I just want to say some infos to the board and also to the soldering process. I will try to make it as viewable as possible, but I think that will be very hard because the camera is in the way. I have a normal soldering tip. It's a ERSA MS8000 and I have this solder, I don't know the size, I think it's 0.5 millimeter. Normally I use a 1 millimeter in diameter, but that's a little bit easier. At the beginning I always start with the chip itself, because when there is a solder bridge between the pins you can remove it better if it's not in the way of other parts. One thing at the beginning, this PCB has an error. The ground plane of the ground and of the top side, so of the bottom and the top side, is not connected, and the USB connector is also on the ground side, not connected to the ground plane of the PCB. That's an error in the PCB design tool. For this I will use, or I will scratch away, or have already scratched away a little bit of the solder mask and will just bridge it here, and on the other side I just bridge it with the capacitors. So on both sides, though, it looks a little bit better. And I will bend also the USB connector a little bit over, so it's more flat, and also it's a little bit stiffer to plug it in the PC. The other thing is that these pads from the USB plug are the exact same size of the connector pins, and it's really hard to get the solder under it. So I will do it that I first tin these pads, put the plug on it, and then will solder it again so it will reflow and will connect better. Yeah, so now I will try to start and see how it goes. Also here I will first make a little bit solder on it, that pad, and we'll try to focus the camera a little bit more. It's just a Galaxy S phone, so not the best camera for this job. It's really hard. The camera is literally 5 centimeters above the PCB. Also I have these tweezers. They are really good, but you can find a lot of fakes of them. This is a fetus or fetus, I don't know how you pronounce it. It's an ESD15, that's the name of this tweezer. It has a bend, or the bend in the end. I don't know how to call it. Now I just try to align the chip on the PCB, and that looks pretty good. And Then I will tin, oh sorry. Yeah, another thing is the direction of the chip. I removed every description on the PCB, so because then it's more space. But you can see here that little dot, that is a 1 pin, and also on the chip is this little dot, that is also the 1 pin. It's hard to see, but it is there. You just have to know in which direction the text goes, and then it will work. Yeah, on the other side I will just tin a little bit every pin, and if there are any bridges, they can easily be removed by reflowing them and pull them a little bit out. I know some big guy says use a lot of flux, but I'm not that a friend of that. Because after you apply the flux, it is very hard to get it away from the PCB. It will always be a little bit gluey. So now I'm just doing the other side. And I really have to say it's hard to do it with the camera. So, but that looks also very good. I will try to show it a little bit up close. Yeah, those parts look fine. The next thing I will solder are these capacitors that are 100 NF ones, and you need 2 pair board, because on the board is one 5-volt rail and one 3.3-volt rail, and the chip datasheet says you need on both of these rails one capacitor. I use 0605 ones, I think, but the space on the PCB is 40805. It's I don't know the exact numbers here. I lay them to the right direction, and I definitely had to solder first, put solder on one pad, so it's easier to get it there. So like this, and then you can put solder on the other side of the PCB. Also, the 3.3 volt rail is coming out of the CH552 chip. It has an internal voltage regulator that also can be turned on or off via the code, and I'm now seeing that I put the capacitor on the wrong pad. I will have to redo this. Yeah, that's better now. The direction of the capacitor is not important because it just have one side. Or it's I don't know how you say it. Ist egal. So now are both sides correctly soldered, and here again I will try to show it up close. It's not the nicest solder job, but it's okay. The next thing I will solder are these 1K resistors. They are for the LEDs, and there it is also not so important in which direction they go, and you will need 3 of them because we have 3 LEDs. And the pins from the LED is 3.0 and 3.1 on the chip, and one LED is directly connected to the 5-volt rail, so that cannot be switched or anything, but it's good to see if the chip has power. So even if you don't have any code running on the chip, it will be recognized that the USB plug has power. It could also be just not soldered, but I think then the PCB doesn't look so nice when the part is missing. Okay, I will now solder the other side, or the other resistor for the other control-abled LED. Also, the direction is not so important from the resistors. And they are pretty easy to solder because they just have these 2 pins. Then the third resistor is going on this place. I will now first tin a little bit one side like this. And I am also trying not to shake the camera too hard. It's really wiggling. Okay, that doesn't look too bad. I will first solder the other side again, so it can get a little bit in the middle. In the solder there is a little tube, and inside of it there is some flux, so that is the dirt you can see everywhere. That is easier to remove than the external flux you would apply. I will just tin a little bit every pin, so it will look a little bit nicer. So then are the LEDs left. They are also 0605 ones, and I have here blue ones and red LEDs. And here is very important in which direction I am soldering them. I will make the red LED as a power LED, and if you can see it right, they have a green part inside of it, and also on the bottom is kind of an arrow. And if we can look closely here, we see that the green part is the negative of the LED. It's very hard to see, but the green part needs to go to the negative side. In this case, it would be this direction. I will just check it again without the camera. Yeah, the green part needs to go there. And that is really heavy to solder with the camera. Also, it's very important to not overheat the LEDs. They are kind of fragile and only short amount of heat or short heat pulses are good for them. But it is definitely possible. They have some kind of round pins. I will try to show it on the other ones. Yep. So, okay, maybe it is possible to see it. They have a little bit round pins. They are kind of flat, but in the middle there is half of a hole, and that is very good to get the solder in it. It's just too tiny. Here you can see it a little bit better, and also the green part. And the solder needs to get into the middle, and then it's kind of easy to solder them. Okay, then there will be here is also the green part, but first I will tin one side again and also from the other one. And I hope I'm doing it the right direction. So, like this. I will directly solder the other LED. I am very surprised by the brightness of these tiny LEDs. And they consume about 2 milliampere if you power them from 5 volts and within 1K resistor. It is nearly too bright to really use them because it's blinding, but you can make them less bright if you use the pulse width modulation or put another resistor on them, so it will be not so hard for the eyes. Okay, now only left is the backside, the switch and the other resistor, but first I will solder the USB plug. It needs to go through the big holes, and as I told at the beginning, I will first flux the pads on the PCB. I will do this right now. So this minus, in the middle are the two data pins, and on the other side is the 5-volt input. Okay, I will try to show it as much as possible what I do now. Okay, I'm holding it from the back and also the USB plug itself. And now I'm pressing it against the PCB. And while doing this, I am reflowing all 4 connectors at once. Like this, and it's getting really hot on the fingers, but as you can see, the 5-volt one is not really nice to look at, but it can be reflowed. So like this. You can be sure if you first tin the pads that they are really connected. Now the next thing is that I'm bending these leads over. I will try this off camera because it's not so easy otherwise. So like this. They are bent to the middle, both of them, and can be now soldered to the PCB. In the next revision I will make, they will be definitely earthed or at the ground plane, because that's not right. But I didn't saw this until the PCB came to me. So that looks kind of good. And now I will also connect the capacitors with the case of the USB plug. That doesn't look nice, but it works. And it's the only easy way of connecting or making the PCB work like it is. Okay, it takes some practice. But we will get there. Yeah, like this. Now it's really connected. I will do it on the other side too. It also gives a little bit more stiffness to the PCB, but that's not so important here. It's more like in the ground connection that is missing. So that was a little bit easier. It's now directly connected. So maybe remove a little bit of the solder. So now is the USB connector perfectly soldered, or kind of perfect, to the PCB, and the only thing left is the 20k ohm resistor and the switch. The 20k ohm resistor is needed for the bootloader entry, and to enter the bootloader it is needed to just bridge those two pins at the power up, and I will do it with a tweezer, or that's the way I do it. You can also put some pin headers there, but it's easier with the tweezer. And also it is possible to enter the bootloader via the program, so you don't have to use a tweezer every time if you, for example, use the button, or you can also send a USB command and it will go into the bootloader mode. And now I'm opening the 20K resistor package, and we'll take out one resistor for the bootloader connector. Here also it is needed to tin one pad, and there's the resistor. The 20K ohm resistor is a 2% precision one. I think they were only in stock, so I chose this type. That's because that's the reason for the big number on the resistor. You can get a little bit irritated by them. So now the resistor is also in place. I have these push buttons, and it gives them into options, or maybe there are more. One is with a very small or short push pin, and this is one with a 3mm one, I think. It's way easier to press this button than the one with a small button. I don't have one right here, but it's just easier. I will also place them on the board, on the PCB, and bring it in the right position. It's nearly perfect, so that's better now. And then I can solder the other 3 pins to the PCB. Also, the push button doesn't use any external resistor. I use the internal pull-up resistor for it. But this works. Okay, so now also I can snap these two PCBs off another. It's just easier to solder when the PCB is a little bit bigger, because that's very small. Also, the touch buttons are just 2 copper pads on the PCB and are just connected to 2 pins. They are very precise, and you can tune them in the program. So they are ADC inputs, and you can put a threshold, or say you want a specific threshold, so they don't register wrong inputs, or they are more precise. Okay, that's now for the PCB part. Afterwards I will clean it a little bit with acetone or some other alcohol. You can get acetone in the building shop, and 99% alcohol is available in the Apotheke. I don't know the English word right now. I will just Google it for you. Okay, in the pharmacy. So you go there and you say you want high precision alcohol, and they will order it for you. So in Germany it is this way. Maybe they will ask why you need it, because it's dangerous, but it is useful for this. And you can say you will clean PCBs with it. Yeah, okay. So now let's try to get the camera at the right angle. Hi, here I am. This is the new PCB. And I have this USB connector that is directly connected to the PC, and also I have the programming tool open for the CH552 or the series. And as I say, the first time the chip gets powered up, it will go into the bootloader by itself, because the program part is empty. If I now plug it in, it should light up. And also here is a new device connected there, and I have one program loaded, and if I program it into the chip, it will restart and will put something out on the serial port. This blue LED is connected to this transmit pin of the UART, and the other one is going to be turned on or off if I press the button on the back. So I will do this right now if the focus is working. So there it is. And as you saw, the LED is going to turn on after 1 second, and it's hard to see, but the other LED is flicking a little bit because the transmitting of the UART, but it's nowhere else connected, so it doesn't do anything. Okay, that's it for now. I hope this was kind of useful for you. It was more like a test if I can show some solder action, but it's really hard. I think the first thing I need is a steadier camera holder. This is just wiggling around, and that's not nice to use. And yeah, if you like this video, please click the like button. And also, if you have any questions for this chip or anything else, just write it in the comments. Yeah. Have a nice day.